Front engine. The front-engine supercar puts the engine ahead of the firewall with power sent to the rear wheels. It is the oldest layout in automotive history. The Ferrari 12 Cilindri uses a 6.5-liter naturally aspirated V12 mounted longitudinally behind the front axle, sending power to a transaxle gearbox at the rear for nearly perfect weight distribution. The Aston Martin DB12 uses a 4-liter twin turbo V8 mounted similarly. The Mercedes AMG GT, the Bentley Continental GT, the Maserati Gran Turismo, and the original Chevrolet Corvette through Generation 7 all use this layout. The advantage is interior space and luggage capacity. A front-engine supercar can offer 2+2 seating, a real trunk, and the kind of ride comfort that allows long-distance grand touring across continents. The disadvantage is weight distribution. The engine is the heaviest single component in any car, and putting it over the front axle creates a tendency to understeer in hard cornering. Engineers solve this through transaxles, lightweight aluminum and carbon fiber construction, and active suspension systems that constantly redistribute weight in real time. The front-engine supercar is the choice when the car must serve as both a daily driver and a weekend track machine. The driver who buys an Aston Martin DB12 does so because they want to drive it from London to Saint-Tropez without back pain, then attack a mountain road on the way home. Ferrari, Aston Martin, Bentley, Mercedes, and Maserati continue to build front-engine flagships specifically because that buyer exists in significant numbers and is willing to pay for a car that compromises ultimate lap times for usable everyday luxury. There is also a subcategory called front mid-engine, where the engine sits behind the front axle but ahead of the cockpit. The Chevrolet Corvette C7, the Honda S2000, the Mazda MX-5 Miata, and the BMW M3 are technically front mid-engine cars. They achieve 50-50 weight distribution by sliding the engine as far rearward as possible without intruding into the passenger compartment. Mid-engine. The mid-engine layout places the engine behind the cockpit but ahead of the rear axle between the driver and the rear wheels. This is the classic supercar configuration. The original mid-engine production supercar was the Lamborghini Miura in 1966. Ferruccio Lamborghini commissioned the layout because his engineers had stolen the idea from racing cars, where Cooper and Lotus had been mounting engines behind the driver since the late 1950s to win Formula One championships. The Miura proved that the same configuration could work for a road car, and within 10 years, every serious supercar manufacturer had switched to it. Today, Ferrari uses mid-engine for the 296 GTB and SF90. Lamborghini uses mid-engine for the Huracan and the new Revuelto. McLaren uses mid-engine for everything they build. Pagani uses mid-engine for the Huayra and Utopia. The Ford GT uses mid-engine. The Bugatti Chiron uses mid-engine. The advantages are overwhelming for performance. Putting the engine in the middle of the car creates near-perfect 50-50 weight distribution, lowers the center of gravity, and minimizes the polar moment of inertia. Polar moment of inertia is the resistance to rotational change. A car with low polar moment of inertia changes direction faster than a car with the same weight, but the mass distributed at the extremes. Imagine a barbell versus a kettlebell weighing the same total amount. The kettlebell rotates faster because the weight is concentrated. The mid-engine car is the kettlebell. The disadvantages are practical. There is no rear seat. There is barely any luggage space. The engine sits inches from the driver's head, generating heat and noise that flow directly into the cockpit. Visibility to the rear is compromised by the engine bay. None of these matter to the buyer of a mid-engine supercar because the only thing that matters is the way the car responds when the driver turns the wheel. The engine in the middle of the chassis allows designers to create the dramatic proportions that have defined supercar styling since the Miura. Long rear deck, short front overhang, aggressive cab forward stance. The engine in the middle of the chassis allows designers to create the dramatic proportions that have defined supercar styling since the Miura. Long rear deck, short front overhang, aggressive cab forward stance. The visual identity of a supercar is inseparable from the mid-engine layout that produced it. Rear engine. The rear engine layout places the engine behind the rear axle, hanging off the back of the car like a pendulum. Almost no manufacturer uses this layout for a supercar. There is one major exception. The Porsche 911 has used a rear engine layout continuously since 1963. Every other manufacturer abandoned rear engine sports cars decades ago because the layout has a fundamental physics problem. With the engine hanging behind the rear axle, the car has a strong tendency toward oversteer, especially on liftoff and mid-corner. The rear of the car wants to swing around the front. Early Porsche 911s were notorious for unpredictable handling at the limit, and several famous racing drivers crashed them in conditions that would not have caught out a mid-engine car. Porsche solved the problem through 50 years of incremental engineering. Modern 911s use sophisticated electronic stability control, rear axle steering, and active aerodynamics to compensate for the layout's natural tendencies. The advantages of rear engine are real. With the engine over the rear wheels, the rear tires have enormous traction under acceleration, which is why 911s are notoriously fast off the line. Braking weight transfers backward to the rear tires that already have the engine sitting on them, providing better braking grip than a front-engine car can achieve. And the layout opens up enormous front trunk space and a small but real rear seat that no mid-engine supercar can match. Porsche keeps the rear engine layout because the 911 is fundamentally defined by it. Changing the layout would mean building a different car. Every other manufacturer reached a different conclusion decades ago. Bonus: hybrid mid-engine. The newest layout combines a mid-engine internal combustion engine with electric motors mounted on the front axle. The combustion engine drives the rear wheels. The electric motors drive the front wheels. The result is all-wheel drive without a mechanical drive shaft connecting the front and rear, with the additional benefit of instant torque fill from the electric motors before the turbocharged combustion engine reaches full boost. The Ferrari LaFerrari, McLaren P1, Porsche 918 Spider, Ferrari SF 90 Stradale, McLaren Artura, Lamborghini Revuelto, Ferrari F80, and McLaren W1 all use this layout. It is now the standard for hypercars. Total system output for the most powerful examples exceeds 1,200 horsepower. The hybrid mid-engine layout combines the handling advantages of mid-engine with the traction of all-wheel drive and the throttle response of electric motors. It also adds significant weight from the battery pack and motors, which engineers offset by integrating the battery into the carbon fiber monocoque as a structural element. Whether this is still a supercar layout in the traditional sense or whether it is something genuinely new is a question manufacturers and journalists are still arguing about. What is certain is that no manufacturer building a hypercar in the 2020s chose any other configuration. The future of the supercar may eventually move to fully electric powertrains, where engine layout becomes irrelevant. The Rimac Nevera and Lotus Evija already point toward that future. But for now, the four layouts described here, plus the hybrid mid-engine variation, define every supercar on the market.